Hello, everyone. Welcome to our 8th International Conference on Natural Resources and Sustainable Environmental Management and 5th International Conference on Water Problems in Mediterranean Countries. Today, we have successfully completed 3 sessions, Session 1, Session 2, and Session 3. Now, we will be proceeding with Session 4. Our first presenter will be Professor Ersi Kalfaoğlu.
Can I start, Sharma? Is it clear? Chairman, could you please reply to me?
Yes, Hocam. Sorry for this inconvenience. There is like a little bit confusion. Saleh Hocam, yes, Hocam. You can proceed with your presentation.
Thank you, Chairman. Good afternoon, everybody. It's my pleasure to be with you in this event. My presentation will be water resource management challenges and future outlook in Libya. This presentation consists of 7 parts. The introduction, water resource in Libya mainly depends on the groundwater, with about 97% the demands or the water resource comes from the groundwater. Generally, everybody knows Libya in the North Africa with a total area of 1.6 square kilometers, as it's shown in the map. The rainfall in the north ranges between 100 and 100 millimeters, while in the south area, which is mostly desert, from 0 to 10 millimeters. Especially in the last 2 years, there was a rainfall storms in the desert parts. Excuse me, can you hear me?
Yes, we can hear you clearly.
Okay, thank you very much. The population of Libya is about 7.5 million in 2025. The water resource in Libya, in Libya there is no rivers. It's only, and its surface runoff is so limited. Only in the northern part, in the west area and the east area, there are so many springs, as shown in this table, in west of the Libya and even in the east of the Libya. For groundwater, as I mentioned in the first slide, that it consists of 97% of the water demand in Libya. We have 5 groundwater basins in all Libya, where we have so many groundwater aquifers in different depths from 100 meters to until 500 or 600 meters. As we'll see, this map shows the groundwater aquifers, which is called the Shfara Plain, the Dams Plain, groundwater basin, in the Murzik. It's in the south, west south of Libya, in the east of Libya, Jabal al-Akhtar basin, and in Kufra and Bisrir basin. For the non-conventional water resource, we have, as usual, about the desalination and water plants for the sewage, as we will see in the next slide. This map shows the desalination plants. However, there are only these days 7 plants from 11. They are working with a production of 10,000 cubic meters per day. These days, or in the last 2 years, there was a program to rebuild and maintenance of the some desalination plants in order to increase the water production. The Libya projected water balance, as we see here, that yearly the balance is decreasing, as it shows in this figure. For the water quality, in most of the groundwater basins, so many of these aquifers would have a good quality water, and others sometimes it will be more increasing TDS or salty water, except in the north part we have seawater intrusion, as will be explained next time. This is the for the sanitation and wastewater treatment plants. Libya, there are so many wastewater treatment plants. Most of them, they are under maintenance and under construction. The other thing for the water quality is the seawater intrusion, as it's shown in this map, will be more clearly in next slide. This figure shows the water table drawdown yearly, starting from 1957 and 72 and 94. There were this map shows the increasing or decreasing of the water table in the Tripoli area, where we have the high population area. For the next slide shows the seawater intrusion, as we see in the upper one, that in 1957 the seawater intrusion was limited in the northern part near to the sea. However, by time and due to the high groundwater abstraction, the groundwater saltwater intrusion front have been goes down, as we show in the last figure, down one in 1994. And we have also seawater intrusion in most of the Libyan ships along the Libyan coastline in the east and west, and even in the Mediterranean parts. Water use in Libya, generally, the water is using with about 85% for the agriculture activity, and we have a little bit with the industrial and domestic purpose, as it's shown in these figures. This is the agricultural water use and irrigation in the 5 groundwater main basins. Water infrastructure. This map shows the dams. We have almost 18 dams. 2 of these dams have been destroyed during the Daniel storm in 2023 in the Derna city, where we have one of the big problem happens to the one of the Libyan city in the eastern part. For the in most of the agriculture, they use traditional irrigation, and this leads to high abstraction of groundwater. We have also, I think we know that the project man-made river project, where we have three phases. This is the first phase from the south, eastern south of Libya toward the east and middle, Sirte and Benghazi, where we have the second phase. It's in the western part of Libya. This is to carry water from the Hassauna oil fields to the Tripoli and some cities in the western part of Libya. Now these days, it's almost is carrying almost of 4 cubic million cubic meter 4 million cubic meter daily. Planned project now the man-made project or authority is planning to have other two parts as soon as one of it in the eastern and one of in the western of Libya. Water management and change in Libya since 1972. General Water Authority has been initiated. This is the only authority in Libya used to making some research studies and even to give a permission for any kind of water supply, wells, etc. Lastly, in the 2012, a new ministry, we call it Water Resource Ministry, have been established and still up to now, which is governing all the water subjects in Libya. Water challenge in Libya. However, while the rainfall is limited, even in the northern part, it not exceeds the maximum was 500 millimeter yearly, but as an average, it's almost 250. It means that even, as example, this year we have only one storm. We are now in December, at the end of the year, and still we have only one storm with a limited rainfall. So this leads to more groundwater abstraction and water drawdown, and this leads especially in the northern part of Libya or the northern cities, leading to the seawater intrusion. So we are suffering from this problem. Most of the Libyan water resource problems is due to the groundwater management. It's not stabilized. There was always some changes from the authorities. So the challenge is water scarcity and excessive groundwater abstraction, indicate institution framework, seawater intrusion and water quality deterioration, illegal use of groundwater, poor crop yields, and groundwater raising problem recently happened in 3 cities in Libya. And this is, as I said, that the groundwater management is one of the most important points to solve all the Libyan problems. For the water strategy framework, there was a water strategy, the water resource strategy from 2000 to 2025 this year. Now there are 2 strategies under construction. One of them is done by the UNDP, it's under federation, and the other done by the National Economic and Social Development Board. Climate change, this subject is known by everybody, and you know that Libya is suffering from climate change as the most countries, especially in the Mediterranean area. However, Libya is suffering from the climate change since more than 30 years due to the increasing of desertification. The desertification is moving from the south to the north, and this is also led to decreasing of the plants covers or agriculture covers, especially in the northern parts. For the shared water resource, Libya have two well-known shared aquifer, one of the west of Libya, sharing this aquifer, Libya, Tunisia, and Algeria. And east part of Libya, we have also sharing aquifer with Egypt, Sudan, and Chad. Both two transboundary aquifers have authority with those countries, and it's working, doing good management to be as a plan for every country to use the groundwater from these two transboundary aquifers. For the conclusion, Libya's biggest challenge lies in developing its water resource sector. So many studies or international projects have been done, and some of them is still under work. Two projects with I have been dealing with. One of them is with the FAO and with the Horizon Europe, leading to water resource or management of the water resource. For the long-term strategy, we have, first of all, we have to make a developing human and institutional capability in the field of water resource, and this is one of the most important points. We hope that to reducing water shortage, developing and upgrading traditional and non-traditional water. One of the subjects is now we are working water, energy, and food mixes. Especially, we have so many water have been consumed during the oil exploration. So we are working to have the mixes for all these three most important points: water, energy, and food mixes. Thank you, Chairman, and everybody. Thank you, everybody.
Thank you, Saleh Hocam. Thank you so much for your presentation. As always, we would like to see you on our next conferences as well. Thank you very much for your contribution. Our next presenter will be Professor Ersi Kalpoğlu.
Hello, and thank you for having me here. I'm very happy to be with you. I'm a forensic scientist, but in dealing with crime. So you would say and you would think that crime is what you know, what is something like killing people. Maybe, but this is in an individual basis. Environmental crime, on the other hand, is a global problem, is a global issue, and a global crime. Therefore, I feel that I'm within, as a forensic scientist, having in mind that crime should be combated anyway. I'm going to talk about PFAS and the environmental health issue, and I will start by talking about DuPont, and we go all the way back to 1936. In this company, which is in the United States of America, there is a scientist called Roy Plunkett. Roy Plunkett is experimenting. He is working with a molecule that is called fluoroethylene. Working with this molecule for completely different reasons, all of a sudden, completely in his not in his knowledge, he comes out and he finds a very interesting material. This material is the following. Actually, he was working with tetrafluoroethylene, which is 2 carbon atoms with a double bond and 4 fluorine atoms around. And because of the conditions that the scientists have had, a polymerization occurred. Then after this polymerization, we have the big molecules that you can see here. By the way, the pictures you can find them in the link that I share with you. Now, what happens and why this new material is very important is the following: the new material is inflammable, inreactive. It does not react with anything, acid, bases, etc. Therefore, it's a very, very valuable material. Now, how common this occurs is because of the following. We have two atoms. One is the carbon, the other is the fluorine. In here, we have this kind of a bond, which is a very, very strong bond. And this strong bond makes this molecule completely inert, and this molecule does not react with anything. Now, this very valuable molecule and material started to be used very, very widely at those years in the army. The military uh, decided to use it because of its characteristics in the army and in the materials that are used in the army. However, the name of this polytetrafluoroethylene was not very practical. Therefore, DuPont, the company, decided to rename it and say, take the T, take the FL, and put an on, which was very, very much on mode at that time, like nylon, etc. And they produced Teflon. This is the Teflon that we all know now. Now, for the polymerization of this molecule with the double bonds, we need an initiator. So the initiation is being done with an exothermic reaction. So heat comes out. This is not okay because this finally, for big amounts of reactions, becomes problematic. They have had explosions too. So we had to put it somehow in water. However, it is completely insoluble. It is insoluble in acids and bases. Therefore, it is definitely insoluble in water. So it was not very easily used. It was not very useful once it was only solid in its solid form. There comes another American company, the one that is we all know as 3M, and they help. They do what? They do the following. They introduce another new molecule to the whole issue. This is the PFOA, which is an octanoic acid which has fluorine molecules around, just like the ones that are forming the polymerization. Look at this molecule. This molecule is hydrophilic in the end, the acid unit, and it is hydrophobic in the rest of the molecule. Therefore, it is very clever, and if we put these molecules in a watery environment, in an aqueous environment, then those molecules are going to form are going to be grouped, and they're going to form some environments that will be ideal for the polymerization. Now, you see in the second picture the polymerized material with the initiator as the first reaction and all the surrounding um, water soluble and insoluble bubble that has been done in water. Now, this was an extremely important progress because, first of all, the exothermic reaction was lowered. We have had water, therefore, water absorbs all the energy that is coming out from the reactions. Secondly, our material, our polymer, is now water soluble. Now, this solubility became extremely important because now we were in a position to put this material to any kind of surface that we want. Look, and you can see what is happening here. You put the new water soluble material to a surface, and then what happens is that the polymer that we want, that we know, Teflon itself, is on the surface, is absorbed on the surface. This is what we actually need. We want this inert material to cover up the whole surface. This is what we know actually we're using. And you can imagine now that all the rest is all around. It goes to the atmosphere, and we will see what's going on later on. So we have a Teflonized surface. And you can understand from now on that everything was Teflon. The kitchen utensils were Teflon. All the textile materials that we didn't want them to be the waterproof materials, the oil-proof materials, um, like even the packaging and even the food packaging is now uh, Teflonized. This is a very active and very nice solution. It is, because Teflon itself has nothing to do with our organism. It is so inert that even if you eat Teflon itself, you do not metabolize it. It is nice, it is non metabolizable, therefore, it does not do anything to your organism. There's no biological treatment within your organism, therefore, no problem. You just excrete it from your organism. However, not those molecules that I mentioned before, those that are forming this watery surface for the Teflon itself to be synthesized. The first molecule that 3M introduced is the one that I show you here with the 8 carbons. That is why it is known as C8. Now, C8 is extremely problematic with human organisms, but all living organisms. You see what? This C8 resembles fatty acids. You see at the right? A molecule of fatty acid, something that we have in our organism. This is how we live. And we know how to metabolize fatty acid, but we do not how to metabolize C8. Therefore, C8, as soon as it is introduced to our organism, it is going to go everywhere and accumulate everywhere. Once it is not metabolized, it is accumulating in the organism because it is water soluble. It's not like Teflon, it is water soluble. Now, look, some numbers for you. Um, we look at the kidney cancer risk, and now you see that it is 1 in 14 in male and 1 in 73 in female. This is the risk. But if you're more than 30 years old, and if you are introduced those molecules like C8, then this risk doubles, as you can see here. All All right, we said, and this is very new. I mean, it is like 80s. People realized that yes, this C8 is really a problem for the organism. Okay, we have not to use this molecule. Fine, we do not use this molecule, but we use other molecules that are of exactly the same function. They are equally problematic for the organism, but they're not called C8. They are called Gene X. And actually, here is the thousands of different molecules that do the same thing, resemble each other, and are extremely harmful for our organism. Listen, those thousands are around, but now you can see those that are mostly present in whatever actually we're using today, from lipstick even to lenses. This material is very, very useful, very easy to use, and that is why it is so problematic. Now, where and how are we exposed to these PFAS molecules? Uh, Everywhere, in drinking water, in dietary intake, because dietary intake is completely related to water, in household dust, in all kinds of occupational settings, and if they're chemical manufacturing industries, the fighting, because the powder that we are actually, the foam that we are actually using to extinguish fire is full of the the molecules. Actually, it is full of Teflon. Therefore, the atmosphere is full of PFAS molecules because of this. We get it by inhalation, but we can also have it on dermal absorption, which is still awful. Now, what are the health outcomes that we know? We have kidney and testicular cancers. We have problems in all kinds of uh, genital cancers. We have immunotoxicity, so our immune system goes to negative. We therefore, those two are interrelated. Actually, children do not are not being affected that nicely by vaccines. We have higher infection rates exactly because of our reduced um, immune system efficiency. We have preeclampsia in the pregnant women, and we have problems in the development of fetus in the intrauterine stage. Therefore, we are talking about an awful molecule, and unfortunately, the problem is that we do not have one kind or two kinds of molecules that are we are being exposed. We are exposed in mixtures. In all, whoever is using any kind of material, we are exposed to a mixture of it. And you may understand that um, this mixture may be even worse because it accelerates the actual effect of the molecule. What is the case in Turkey? Do we know? Do we have any um, risk assessment activity? Unfortunately, we do not have monitoring or biomonitoring programs or database or how many people do have PFAS molecules in their blood or in their organs. You know what? Unfortunately, there has been a study in the United States. It's a massive study to see what is the amount of PFAS molecules that are present in the organisms. And unfortunately, they weren't able to find one single person that does not have PFAS in its organism. Therefore, you can understand how big the problem is and how new the problem is actually. So, what we have to do, we have to biomonitor, we have to find what's going on with mixtures, find models about it, make great and big and international risk assessments, establish national guidelines and policies, and try to prevent it, pay for research, try to find out what's going on, and have transparency and communication, which is, as you can understand, very, very, very important. So we have a long way to go. This is a global crime that is going on. And as a forensic scientist, I'm very, very sensitive about it. And I want to congratulate the whole effort. This was a magnificent get together. And thank you for having me here with you. If there are any questions, I'm ready to answer them.
So, Hocam, as always, it was a pleasant to listen to your presentation. It was an interesting and educated. I have been also educated by your person, by the
Thank you so
presentation.
much. Thank you.
Thank you very much, Hocam, as always, attending to our conferences. We would like to see you as well on our next conference.
Thank you. See you next year then.
Thank you, Hocam. Thank you. Dear researchers, our next presenter will be Associate Professor Dr. Mahnaz Gümrükçoğlu Yiğit.
Good afternoon, everyone. I'm trying to share my screen. Can you see my screen? My presentation?
Hocam, not yet, Hocam. You can share it. It sometimes takes few seconds, but not yet.
I can't hear you, and just I can hear my voice.
For your voice, it is easy to fix. You can lower your volume, but after you start the presentation. But first, we need to solve the problem about your presentation. Mahnaz Hocam? Mahnaz Hocam? Yes, Mahnaz Hocam, you can try to share your presentation or share your screen. We have two options. Either you can upload the presentation file, or you can try to share your screen.
I use these tools and for sharing tools. Share screen.
Directly, there is a button to present from StreamYard. From this present button.
Yeah, I did it.
Yeah, from this present button, you can share your screen, but the PowerPoint, of course, should be already open, or you can upload from slides.
This is open.
Okay. If you want, you can share your screen.
Just a minute, please.
No worries, hocam.
The last chance. Last time. Share and Windows.
In Windows,
now?
if you cannot see, let us check. In Windows, if you cannot see your presentation, you can use
Yes, I can
entire
see,
screen.
and now I can see my presentation, and also I share now also the full screens. Now, can you see that? No.
No, hocam, we cannot see.
How
Hocam,
can I
there is
do it?
another option.
No?
There
What
is
is the
another
other
option. The another option is to, again, from the present button, from slides and PDFs. Yes,
yes.
I think it's fixed, hocam. Yes, hocam. We can see it now. You can make it full
there is
screen.
no there is no the slide.
Hocam, we can see it. It's all right. If you press again to the presentation file, after you can make it full screen by pressing F5.
Yeah. Yes, full screen. Okay. Now?
Yes,
Is it
hocam.
okay?
Yes.
No.
You should make it full screen again.
Okay?
Yes, hocam. We can see it. Yes,
Okay.
hocam.
Sorry.
No worries,
Sorry.
hocam. Floor is yours.
Delay.
No worries, hocam.
Good afternoon again, and Mr. Chair and dear participants. First of all, I would like to thank to the Professor Hüseyin Gökçekuş and all the other contributed to organizing for invited me for a very good this valuable congress. Thank you. And my name is Mahnaz Gümrükçoğlu Yiğit. I'm from Sakarya University Environmental Engineering Department. My expertise area is climate science, and I study about the climate change and its impact and carbon footprint and energy efficiency, the environmental issues, especially related to urbanization, and using GIS data or modeling. And now, today, my study in my presentation, the focus on the living cities approach and the discussed major role cities play in the climate crisis, and at the same time, the opportunity areas where cities can generate solution. As you know, the main drivers of the climate change, such as fossil fuels, deforestation, industry, transport, and agriculture, have a much stronger effects in cities because energy use is the high and emission and are concentrated. That's why the cities are both a major part of the problem and places where solution can be scaled up. In cities, climate change shows itself through rising temperature, extreme weather events, and water-related problems. The impacts of those depends on urban density, blue and green infrastructure, land use, and material choices. The build climate resilience against these impacts of the urban life, planning, buildings, transport, and ecosystem-based solution need to work together. The living cities approach supports this by helping planning and design adapt to local climate. The cities effects very important. For example, with urbanization, the hard impervious surface have increased causing rainwater to run off the surface and increase flooding. flooding, not also flooding risk, increased flooding risk. The graph shows a clear change in the peak flow and timing before and after urbanization. The other effects of the urbanization, reducing heating demands on some areas while increasing cooling demands, but in others areas reducing it, increasing the cooling demand, and the others reducing the heating demands. For example, as you see in the graph, the heating demands is decreasing in Istanbul, while cooling demand and related emission are increasing in Adana. If we consider this situation, consider for the Cyprus Turkish Republic, for example, which has also the Cyprus has a Mediterranean climate. And in this area, the hot periods will last longer in the future. It means the needs for cooling, electricity consumption will increase, of course. Therefore, the climate resilient living cities approach in Cyprus urban planning should focus on passive cooling, high albedo surfaces, and energy efficient buildings. Cities today are like this, and but in historical periods, the traditional cities were designed with an ecological approach and were sensitive to the climate. As the photos show that the shaded streets, architecture that balance for solar exposure, windows designs that regulate heat, and buildings constructed with local materials that provide thermal insulation are all examples of climate adaptation in traditional urbanization. Because of the Industrial Revolution, this knowledge was unfortunately pushed into the background. But the living cities approach updates this heritage and carries it into climate resilient urban design for today. Here you can see the settlement of the Kaun city in ancient Egypt. In Kaun streets and the buildings were arranged based on the prevailing winds. They were also positioned to protect the people from hot desert winds. This is an early example of ecological or passive design for natural ventilation and the shade. It means they stay cool without using energy. The living cities approach takes inspiration from historical examples like this, using more advanced methods, of course. Cities created without considering urban design principles, the urban heat island effect occurs. It is a phenomenon that the city centers are warmer than their surroundings, as you see in these graphs. The main causes are dark heat storing surfaces, heat emitted from industry and vehicles, a lack of green areas, reduced evaporation, and weakened wind circulation. As a result, energy use and emission for cooling increased and air quality deteriorated. One of the most important factor in the formation of the urban heat island is urban geometry. In other words, elements such as street canyons and building height and density can slow down the wind and therefore heat accumulates more easily. As you see in screen, if a tall buildings blocks the window of another building's airflow is disrupted. Also in ground level, this can create a strong turbulence. Wind speed up overproof on the sheltered side, turbulence increases. Therefore, it is very important to protect wind corridors along to the prevailing wind direction. It means urban form should be blended together with microclimate analysis. The geometry is very important, but also the material choice for urban ground surfaces also directly affect the microclimate. Dark impermeable broad and sidewall surface store more heat, while high albedo cool surfaces and roofs and vegetation absorb less heat and help reduce urban temperature. As an example, in our study on the urban heat island in Sakarya city, we used Adapazarı district as the urban station and gave as the rural station. We compared long-term temperature, precipitation, wind, and the humidity data. The results show that Adapazarı is warmer than the rural area due to increase the urbanization, the number of the buildings, a rise in motor vehicles use, and reduced wind speeds. The graphs also show a clear increase in the differences between minimum and maximum temperatures. This makes it clear that the urban heat island effects can be observed at the local scale. Every step taken to reduce the urban heat island also helps make cities more ecological. The ecological city is a sustainable living model where energy, transportation, water, waste, land use, and social sustainability are managed together in an integrated and coordinated way. In redesigning a city ecologically, in identifying the city's ecological footprint is a priority. The ecological footprint showed, as you know, showed the biological productive area needed to produce resources a city consumes and to absorb its wastes, making the city's pressure on the climate and the environment visible. Local studies show that components vary from city to city. For example, the city for the Sakarya, it is our study. We calculated the biocapacity required to offset transportation emissions, the footprint from built-up areas, waste and recycled process, and CO2 emissions linked to animal-based food production and electricity consumption. As the graphs show, the largest components were energy use. Therefore, to reduce Sakarya's ecological footprint, it was emphasized the energy consumption and transportation. The alternative solutions should be priorities. The Sakarya case showed the distribution of the ecological footprint components and indicates which areas should be addressed first. The structural indicators of the education ecological cities are the natural ventilation, passive shading, advanced purification systems, green and water corridors, green or white roofs, and waste recycling. One of the main components of the ecological cities is self-sufficient ecological buildings that reduce emissions. As you see in these photos and in screens, these buildings include every production through solar panels, passive cooling, and rainwater storage. Wind options, high-rise insulation, sensor-based systems, and water-saving measures, reducing the dependence on energy and water at the building, increase the resilience of the city. In eco-cities also we should use the railway systems and public transportation, walking and cycle cycle ways for the low carbon transition, along with the cleaner fueled vehicles and underground parking area. The goal here has two sides. The first to reduce emissions. The other, on the other hand, the second, to create a transportation system that is resilient to climate impacts. Climate resilient and resource efficient cities are emerging with different solutions in different regions. There are many examples all over the world. Examples include the cities in the Netherlands, Kazakhstan, Germany, and very special Mostar city. These cities aim to become global hubs, integrating renewable energy, clean technology, and nature-based solution. Nature-based solution is very important. If cities back up the hard solutions such as engineering work with soft nature-based solution, everything becomes much more effective. This includes limiting construction is high risk areas, creating blue and green networks and park corridor systems, setting incentives and standards, and improving education and public participation. For real long-term change, we need to balance technology with nature and keep ecological and social justice at the center of these decisions. In conclusion, more than half of the world already lives in cities, and also this share will keep going. That's why today urban system sustainability is more important. The living cities approach sees the city is not as a fragile collection of buildings, but as a living systems. It argues that all planning should be done with this perspective. This is the end of my presentation. Thank you for listening. If any question, I am ready. Thank you.
Thank you very much. Thank you very much, Mahnaz Hocam. It was a very nice presentation. Thank you very much. It was an interesting topic. Thank you for your contribution to our conference. We would like to see you again in our next conferences. Thank you.
Thank you very much for everything.
Our next presenter will be Dr. Karima El-Masri.
Hello, good afternoon. Can you hear me?
Yes, Karima Hocam, we can hear you, but we cannot see you. Your camera is open, but we cannot see you.
Yes, yeah. Yeah, I've chosen to just to put some like
Uh,
just a picture because I'm not really ready.
okay, no worries, Hocam. The presentation looks
And
perfect. So,
also, yeah, and also due to internet connection in Libya, it's not that present without camera.
okay, Hocam, whenever
Is
you
that
are
okay?
ready. Yes, Hocam, whenever you are ready,
Okay, thank you so much.
you
Thank
can
you
start.
so much.
No worries.
Thank you. So good afternoon, everybody, and thank you for giving me this chance to participate in this conference, a valuable conference, actually. So my presentation or my activity estimation in granite stones used as a building materials imported from Asian countries in Libya. So here is my contents of my and to introduce the study is that you know that there is a radioactive materials. We call it as a norm. It's kind of three uranium 238, thorium 2, and potassium. So type of radioactive materials coming and in the earth crust. Granite, as you know, is extensively used as a building material and also as a decorative material due to its durability and good properties. And this type of rocks proved that it contains elevated levels of norm. And the use of granite indoor environments in like gamma, especially from radon, alpha emitter, and inhaling this type of gases may cause different a lot of health problems, such as lung cancers. Libya usually imported large quantities of granite from many countries, and especially Asian countries with limited radiological screening. Actually, don't have like enforcement for companies to screening on their materials, especially for the building materials. And so, evaluating this type of natural this from the natural radioactivity of important granite to ensure the radiological safety and support building particles. So what's of our study is to measure the activity concentration produced from radon or radium to 226 and thorium 2, which is already represented by 28 and also potassium 40. And then evaluate the radiological hazards indices associated with the use of granite as a building material, and also to assess the compliance of important granite with international radiation safety standards and provide scientific recommendations to support safe and sustainable constructions particles in Libya. So the methodology of this. So we, in this study, we studied a lot of samples. Just 11 samples were collected from the commercial suppliers, especially imported from different Asian countries. And these samples were prepared by crushing, drying, sealing, and also stored for more than 1 month for or to achieve the secular equilibrium. And then the activity concentrations were measured using a system of high purity germanium gamma spectrometry. And then we calculated the radiological hazard indices, the R equivalent, which is of radium equivalent. And now I will present samples that we measured in this study. So most of these were from India and just two from one and Uzbekistan. For sample analysis, we relied on the high purity uranium with 76 measured relative efficiency on the energy of cobalt 6133 MeV, and the energy resolution of the detector was perfect between 1.8 and 2.1 kilo electron volt. Several characteristics gamma ray lines were used for uranium 238, which is radium, almost radium 226 series. We used the different energy lines produced from the bismuth, one of the most products of uranium 238, and for thorium 232, we used the most intensive the most important and intense 911 and 968 from the actinium, and for potassium we use 1,4, which is about 10% of the appearance for this type of radioactive materials. And the measured activities then were also compared with the international safety limits. The produced in 2008 is 33 becquerel per kilometer uranium and 45 becquerel per kilogram for and 424 potassium. So here is the measurement, how we calculate each element. So we used this equation, calculated the area under the peaks of each energy, and also we subtracted the background, and for our measurements was overnight for 24 hours. For each element, we use the same equation, but different energy lines, and the radiation hazard indices were calculated starting from the radium activities. Is there any problem? Hello?
Karim Hocam, everything is going great. There is no problem at all with your connection.
Okay, thank you so much. Sorry. So let's go to the results. So what we found, most of our samples, radium, thorium 222 and potassium, shown a considerable variation among the granite samples, reflecting difference in geological origin. And the granite imported from Pakistan or Uzbekistan generally exhibits low radioactive concentration. So from this, it's clear that most of Indian samples were or exhibited high radioactive concentration. And for to do more calculations, also measured the potassium, so higher in some samples, so remained in many samples under the or below the UNICEF limits. Equivalent, which is important for if this or samples are in permissible or accepted levels. So we found that the lowest R equivalent value between 10, and the highest was followed by 31 from Uzbekistan, which were very low radiological hazards, and most of one from India exhibits more than 370, which was 488 becquerel per kilograms. The external hazard were also calculated, and the same sample recorded 131 from India, which is higher than the permissible from the international UNICEF and other committees. For the absorbed dose also, the absorbed dose rate ranges from 4.8 to 221 nanogray per hour, and the lowest was from Pakistan and India, respectively. The mean absorbed dose was about 62 nanogray per hour, while the lower UNICEF global level average level were 84 nanogray. So it was within the limit. The annual effective dose rate also was between 0.02 millisievert per year to 1.16 millisieverts per year. And from this calculation, we can also calculate the excess lifetime cancer risks. So ELCR represents the probability of cancer risk over lifetime due to the ionizing radiation exposure, and it was changing between 0.11 to 5.13 in some samples. One of the samples from India, the ELCR was 5. Pretty high. So to conclude this study, several granite samples from India showed radium-226 activity exceeding than 80 becquerel per gram, and 2 of these samples were exceeded the recommended limits for thorium, and only 1 granite sample originated from India exhibited radium equivalent activity above the recommended, which is 370 becquerel per kilogram. And the granite samples imported from Pakistan and Uzbekistan showed lower radiological hazards, while the BGI exhibits elevated value across the multiple hazard indices, including radium equivalent and annual equivalent dose, and also ELCE, which raising the concerns regarding these samples. To conclude, also we have some recommendations about this study to implement mandatory radiological screening of important granite before use in construction, and also enforce compliance with international radiation safety standards for building materials, and restrict indoor use of granite samples exhibiting elevated radiological hazards. At the end is increasing the awareness among the importers, builders, authorities regarding the radiological risks. So here we last slide. So thank you so much for your attention, and ready for any question if you have.
Thank you, Karima Hocam. Thank you very much for your contribution to our conference. Thank you, as always. We would like to see you. We would like to see you on our next conferences as well. Thank you.
Inshallah. Thank you so much.
Thank you. Thank you. Our next presenter will be Dominika Dabrowska.
Good morning. My name is Dominika Dąbrowska from University of Silesia in Poland. And I would like to present the topic, the use of oxygen trees in the purification of soil and water environment in the area of municipal waste landfills. This is the topic prepared with cooperation with another researchers from University of Silesia, Wojciech Rykała, Aleksandra Nadgórska-Socha, Marta Kandziora-Ciupa, and our colleague from Wrocław University of Environmental and Life Sciences, Aleksandra Wdowczyk. Landfilling remains the most widely used method of waste management. Although it primarily concerns developing nations, it is still a common practice across the globe. The core issue, however, one that also impacts smart and sustainable cities, is the very process of waste generation. Even though economic growth has a strong influence on the amount of waste produced, a significant portion of this waste still ends up in landfills. Many landfills, especially old ones, do not have any substrate seals, so pollutants leaching from waste and transferred to the soil and water environment. Typical pollution indicators for municipal waste landfills are electrical conductivity, high concentrations of fluorides, sulfates, nitrogen, boron, chromium. In addition to heavy metals, there are also polycyclic aromatic hydrocarbons. They are among the most common organic groundwater contaminants in the area of municipal landfills. They are used in the manufacture of personal care products, fertilizers, and plastic packaging, among other products. Numerous studies show that these compounds can be carcinogenic and mutagenic. Paulownia oxy tree is considered as a tree of great economic importance, ornamental and high quality wood. It should be noted that Paulownia is also used in herbal medicine and as sedative to animal feed. Ox tree is a tree formed by the crossing of two species, Paulownia fortunea and elongata. This tree produces numerous very large leaves that can reach a diameter of approximately 60 centimeters. In the process of photosynthesis, leaves absorb large amounts of carbon dioxide, hence the name oxygen tree. It is worth paying attention to the fact that the tree tolerates both high and low temperatures, and there's no specific indication of the soil pH value. The tree can be planted in fall or springs. It is currently used as a source of biomass, a tree for the production of furniture, or a tree with properties that absorb carbon from the atmosphere. Oxy tree is a tree cloned under laboratory conditions. In 2015, research was launched in Poland to determine the ability of oxygen forests to cleanse of soil exploited by mining. Heavy metal contamination of soil is one of the most biggest environmental problems. Therefore, research involving an attempt to clean the soil is all the more necessary. It's worth to say that Paulownia has so far only been investigated to a limited extent on mining waste materials. No research has been conducted on the accumulation of novel or rare earth elements. So far, the influence of Paulownia on the possibility of accumulation of pollutant loads, cadmium, plumbium, and zinc in soil mining areas has been tested. Similar studies were conducted in China. We should know that phytoremediation has many advantages, but the biggest problem if implementing this method in soil is finding appropriate plants. In the case of municipal waste landfills, high concentration of contamination, not only with heavy metals, but also with fluorides and ammonium ions should be taken into account. That's why we decided to prepare this research. The aim of this presentation and the article which we submitted to the journal, it's to investigate the possibility of using Pawlownia to clean soil from pollutants, both organic and inorganic, generated during the migration of leachate from municipal waste landfills. The test was carried out with the concentration of leachates and compared with the conditions of watering with distilled water. Research shows that Pawlownia can be used as a plant for remediation of areas around waste disposal site, but only if the appropriate concentration of leachates and selected metals are maintained. The 3 seedlings were cultivated in commercial pit-based substrate. The cultivation was carried out for 60 days at a temperature of 24-22 Celsius degree, depends on the day or night, at a light intensity photoperiod of 16 and 8 hours and a humidity level of 82%. Once a week, the plants were watered with a 100% and 50% solution of leachate, respectively. Substrate without the leachate was established as a control. After 60 days of cultivation, part of the plant materials was stored at minus 80 Celsius degree prior to analysis. The part of the plant material, aerial parts and roots that were for element analysis were washed with tap and deionized water and dried to a dry weight at 105 Celsius degree. If we are talking about chemical analysis of leachates, leachate from the municipal waste landfill in Tychy, it is a city in the southern part of Poland, was used to water the plants. The chemical composition was analyzed for pH, electrical conductivity, sulfates, sulfur, phosphates, ammonium nitrogen, total nitrogen, nitrates, bicarbonates, chlorides, total organic carbon, aluminium, copper, iron, manganese, nickel, strontium, calcium, magnesium, potassium, and sodium. After testing in the laboratory, the soil samples were subjected to bath leaching tests. The static method involves inducing a reaction between the tested soil and the liquid in a closed vessel. In this test, the type of leaching liquid, its amount in relation to the solid phase and the contact time of the liquid with tested sample play an important role. And the static tests were carried out in accordance with the European standard and Polish standard. The leachate used to water the plants had an electrical conductivity of 14 millisiemens per centimeter and a pH of 7.8. The chemical composition was determined primarily by high concentration of fluorides, nearly 2,000 milligrams per liter, ammonium nitrogen more than 1,000 milligrams per liter, and sodium 1,000 milligrams per liter. Ammonium nitrogen is indicated in the literature as one of the main pollutants present in the liquids, usually reaching values up to 1,000 milligrams per liter and decreasing slowly with age. Therefore, even in the liquids from old landfills, it occurs in high concentrations. However, the high sodium content in the analyzed liquid may indicate the presence of plant residues and other bio-waste in the landfill, and confirms that even with the passage of time of landfill operation, it's not subject to change due to the process occurring inside. The calcium content remains at similar level in both landfill leaching and leachability in the samples. The leachability of magnesium in the tested samples, it's only 4% of the initial concentration of this ingredient. For potassium, it's about 10%, and for sodium, it is about 6%. How about polycyclic aromatic hydrocarbons? A number of these compounds were observed in the tested samples. Polycyclic aromatic hydrocarbons constitute the typical anthropogenic pollutants occurring in the world. Comparing individual group content of the sum of the hydrocarbons, in the control sample, the highest amounts was observed among free-ring hydrocarbons, while the lowest was observed among five-ring hydrocarbons. And this is a sample that has not yet been exposed to leachate from a solid waste landfill. It therefore serves as a reference point for interpreting other sample results. In one soil sample in which plants were planted and watered with diluted leachate in a ratio of 50-50, their quantitative increase was observed in one ring group of hydrocarbons out of 4 to ring. However, in the remaining cases, a significant decrease was recorded. Changes in the level of soil properties in the environment may result from the partial replacement of the liquid in the soil pores with hydrocarbons and their blocking with other pollutants. This may lead to the decrease in soil aeration and water infiltration. Research shows that plant roots are a common route between the soil and the plant, as the tissues that first connect with pollutants during the gathering of hydrocarbons found in the substrates. And the greatest percent change compared to the control sample was in the group of 4 and 5 ring hydrocarbons. However, different situations occur with 2 rings naphthalene, wherein both samples increased by more than 30% in 50% concentrations of leachates and about 7% in the case of 100% sample. This may be due to the chemical properties of high molecular weight hydrocarbons and their relatively low solubility in water. Phytoremediation technology is a method that uses plants in the process of purifying the soil and water environment. we should know that this technique is ecological and cheaper than other chemical and physical treatments. In the case of macronutrients, an increase in the concentrations can be observed with increase in leachate content. For calcium, an increase of approximately 24% was observed compared to the control sample. For nitrogen, an over five-fold increase in the content was observed. Increases were also observed for the remaining macronutrients. Phosphorus content was higher in the 50% sample and then in the 100% sample. No uniform rule can be derived for micronutrients. In the case of iron and manganese, slight difference between the variants were observed. Minimal fluctuations were also observed for copper. In the case of lead and zinc, an increase in soil content was observed in the 50% and 100% samples. For lead and zinc, this was a very significant increase by approximately 50% for each nutrient. The opposite trend was observed for iodine. The content of this component decreased with increasing leachate concentrations. Here we can see selective increases in aerial plant parts at elevated leachate concentration in the case of potassium, sulfur, phosphorus, lead. We can say that roots serve as the primary defense barrier and accumulation sites. Primary accumulations in the case of magnesium, sulfur, and phosphorus, so we observe significant increases. In the case of phosphorus, it was nearly doubled at 100% sample. The greatest accumulation in roots in the case of nitrogen, and decreasing trends was observed in the case of aluminium and iron. However, in the case of lead and copper, it could be treated as the heavy metal barrier. It was observed a significant increase at 100% leachates in the case of lead. And in the case of copper, the increases with leachate content concentration was observed. Proline and amino acid accumulated in plants under the influence of osmotic or toxic stress, natural antioxidants such as phenols, flavonoids, and ascorbic acid, as well as a marker of cellular damage, malondialdehyde, were taken into account. Physiological parameters such as MDA and proline content serve as important indicators of plant stress. MDA is a byproduct of the peroxidation of polyunsaturated fatty acids resulting from reactions with reactive oxygen species, which act as early signal molecules in the plant stress response. Total phenolics and total flavonoids exhibit strong redox properties, functioning as reducing agents and hydrogen donors. Together with ascorbic acids, these compounds represent essential components of plants that contribute to a wide range of beneficial physiological and health promoting effects. The increase in prolonged levels at 50% and 100% samples indicates a planned defense response to environmental stress caused by the presence of heavy metals or salts in the leachate. The phenol level decreased with increasing leachate supply. The decrease in phenol content with increasing leachate concentrations may be due to phenols being used to neutralize oxidative stress, but also to the inhibition of their biosynthesis by the presence of heavy metals in the samples. Similar situations occurs with flavonoids. Change in ascorbic acids in the samples may indicate an attempt to antioxidant compensation as a response to decreasing phenol and flavonoid value. We can say that total phenols level decreased significantly with increasing leachate supply. Similar to this, flavonoid content drop as leachate concentration rose, and ascorbic acid showed only slight changes. Studies on Pawlownias show that they perform less well in environmental purification than phytoremediation grasses. Numerous studies conducted worldwide on grasses, grass Sativa domingensis, Rhodes grass, and elephant grass indicate the potential for environmental purification, not just the accumulation of pollutants. Research conducted worldwide is consistent with the result obtained in this study. In the case, the results showed that at least concentration exceeding 400 milligrams per liter, chloroplast enzyme activity is inhibited and chlorophyll content is reduced, thus accelerating leaf senescence and inhibiting plant growth. The study of Pawlownia tomentosa did not take into account low leachate concentrations, which could trigger the phenomenon of hormesis. Such studies at leachate concentration of 2.5% and 5% were conducted in another studies, and the results should be compared with the results of our studies. In this slide, we have got key findings from the study and the specific complex patterns of accumulation and stress response, which indicate limited susceptibility at high concentrations. So our next task should be checking the low concentrations of leachates from municipal landfills and checking the behavior of Pawlownia trees in such experiment. The study revealed differential patterns of contaminant accumulation in Pawlownia plants and soil. In the soil, calcium, lead, and zinc increased at higher leachate concentrations, while iodine decreased. Macronutrients such as potassium, sulfur, and phosphorus increased in stems and leaves, with phosphorus nearly doubling at 100% leachate concentrations. Stress biomarker analysis revealed that Pawlownia exhibited a defensive response to environmental stress. Proline levels increased significantly at 50% and 100% leachate concentrations, suggesting a response to heavy metals or salts. However, phenol and flavonoid levels decreased with increasing leachate concentrations, likely due to the consumption in the neutralizing oxidative stress or inhibiting biosynthesis. MDA values, a marker of cell damage, show a surprising decrease at higher leachate concentrations, particularly 0 at 100% concentrations of leachates, suggesting extreme chemical stress leading to damage to the antioxidant system and cell death. Research indicates that oxy can be used for environmental remediation in landfills, but its effectiveness is limited by leachate concentration. These plants selectively accumulate inorganic pollutants primarily in the roots, meaning they are not effectively removed from the environment. However, it shows promise in removing hydrocarbons from areas near solid waste landfills. Further research is recommended to precisely determine the occurrence of hydrocarbons in soil and identify plants that can effectively neutralize these pollutants from the ground. The study also highlights the need for careful consideration of leachate concentration and specific contaminants when using paulownia for phytoremediation. And thank you very much for your attention.
Thank you for Dominika Dąbrowska's presentation. We have successfully completed session 4. Now we will be proceeding with session 5.